Hello, welcome back to the channel. If you are an expert in data analytics and you want to use your skills to help executives understand their business and support their decision-making process, you are in the right place. In this video, we are going to use a real example of a medium-sized company based in Paris. They ask my support to solve their cash flow and inventory problems. We will see how we can develop a model to simulate financial flows and support business planning by properly stating the problem we want to solve, by asking the right questions and translate business language into algorithmics or analytics. Use the model to simulate the entire value chain of the company and try different scenarios to find the optimal setup that would maximize growth and profit. I will use the demo version of the LogiGreen app. This is a web application we developed in our company, LogiGreen, that is based in case studies presented in this channel. Let's go. First, let's introduce the context. So my friend is selling cups and straws made from renewable products to replace plastic. They are sourced from a supplier based in China. They are delivered by sea freight or air freight to a warehouse based in Paris. For the distribution, they work with a transport company to deliver their products either to coffee shops and bars that are direct customers or to distributors. So what's the problem? If I quote my friend, he would say, we don't have enough money to order more products. So this is a cash flow problem. This is the biggest bottleneck for their growth, because if you don't have product to sell, you cannot increase your turnover. And they also have a problem with the sales channel strategy. Basically, when they sell to direct customers, they are losing a lot of margin because they work with sales representatives. Let's see how we can use analytics to support them. After multiple discussions and interviews with him and his employees, I was able to reconstitute the cost model of the value chain of this company. So first, everything starts with the supplier, that invoice per unit produced. Here, we don't have anything to do because it's mainly based on the negotiation between my friend and the supplier. Then you have the freight cost. So here it's mainly depending on the transport mode that you want to take. It's a compromise between cost and efficiency. If you go by sea freight, which is cheaper, you have to wait 4 weeks to be delivered. But if you go by air freight, it's only 1 week, but it's nearly 3 times more expensive. Here, we have our first parameter that we can use to leverage the optimization of our model. And this parameter will affect the second one, which is the inventory management rule. So when do we send replenishment orders to the supplier to ensure that we have enough stock to meet our customer demand? This will depend on the demand variability on the right, but also on the transport mode on the left. Then we have the way that we deliver our customers. So here we are working with a transport company, but what we can see is that the pricing of the transportation will depend on the size of the shipments. So if you have larger shipments, it will be cheaper per pallet or per unit delivered. And finally, the last level of optimization is the sales channel strategy. My friend has 2 choices to sell his product. Either it's direct sales, so he's directly selling to coffee shops and bars, but for that, he's working with sales representative. So these sales representative don't have any salary, they are paid by commissions. They take 30% of commissions. When you work with coffee shops and bars, it's pretty cool because they pay at the order time. But the order quantity are limited and you need to pay the commission. That's why he found another sales channel that is basically selling to distributors that will then sell to the different coffee shops and bars. The problem is that the distributors paid only 4 weeks after delivery, but they don't need any commission. And their order size is bigger. So basically, in terms of shipment optimization, is also pretty good. So as you can see here, when you look at the different blocks of optimization, it's pretty complicated for a business owner that has to manage on the daily basis his business to take the right decision. Therefore, we have the way to support him by using analytics. Let's go. So one of the main issues of my friend, if you remember the quote, is liquidity. That is linked to freight costs that are based on the service level. So if you are using air freight, you have a better service level. You are delivered in 1 week. When you are using sea freight, you are delivered in 4 weeks, but it's cheaper. And then it's also linked to the fixed and non-recurring cost. Here we are not going to touch that. It's not part of the optimization model. But it's also linked to the revenue. So if you are working with distributors, you have higher revenue per order, but you are paid 4 weeks later. But if you are working with direct sales, you have the cash on order. So you are paid fast, but the margin is lower. So here, this is too complex for my friend that has to handle these daily issues that I said. So let's try to modelize all the different blocks and test multiple scenarios to see which one could be the most optimal. As a first step, as a supply chain data scientist, I developed a model for the inventory management. So every time the order is below a certain quantity, my friend, which is checking nearly every day the inventory level, is sending an order to the supplier. For most of the time, their order quantity is to cover 8 weeks. What we are going to do is first to replicate the behavior of my friend and see if we can improve the model. For that, we are going to use different parameters. So the lead time for replenishment. So here, if we are working with freight forwarders for sea freight, we have to wait 4 weeks. But if we are working with air freight, we need 1 week. And of course, we are going to use the customer demand variability. So my friend gave me the average outbound volumes per week. So I was able to basically estimate what would be the demand variability. And then we are going to set the order quantity. So initially, to copy what my friend is currently doing, we are going to take 8 weeks of average daily sales. Let's go to the code to see how it works in reality. So let's translate what my friend said. So he said that they are continuously reviewing the stock every day. And each time the stock is below a certain amount, they order to cover 8 weeks of demand. So in supply chain analytics vocabulary, that means that they are using a continuous review policy in terms of inventory management. If you are not familiar with that, I have an article about it. And when they say they want to cover 8 weeks of demand, that means they are ordering for 8 times the weekly demand. So if you're not familiar with the continuous review policy, it's basically an inventory policy for which you are checking the inventory level. So let me go here. This is, for instance, the right example. You are checking the inventory level. So here IOH means inventory on hand every day. And each time the inventory level is below a certain threshold, you are reordering. And here in blue, you have the reorder point. So that enables basically to meet the demand to meet the variability to basically absorb the variability of the demand, ensuring that you don't have stockouts, because here you can see that inventory level is higher than 0. And here, what's the main parameters that are influencing that? It's the average demand. So here you can see like the mean of this chart, but also the demand variability. And here we can see the variability is very high. So when you are doing this calculation, and I won't detail here, but you can find the detail in the article, you are calculating the reordering point that is the most optimal. So basically, when you are waiting to be delivered, so let's say if you are waiting 4 weeks for the sea freight or 1 week for the air freight, you can cover the demand, so the average demand, plus the potential variability. So here you start to sense that this inventory level will highly depend on the type of freight you have. Because if you have sea freight, you basically have to wait 4 weeks. So probably this level will be higher than if you are on air freight, where you only have to wait 1 week. And if you are a higher level of inventory of replenishment, that means you need to replenish more frequently. And that can affect the cash flow. But in the meantime, sea freight is cheaper. So here you start basically to sense the different compromise that we will have. So first, let's go to the code. So here, this is the article. Inside the article, you can find the code that is shared on my GitHub. And basically, I replicated this code. I just adapted to the case. So here you have the demand variability you have the demand basically of my friend's number of pallets per week. And here you have the average inventory in hand. So we start with 60 pallets. And here is showing basically when he has to reorder in blue. And here, what we could see is that we still have some leverage if we are switching from continuous review policy to something called periodic review policy. And if you go to my blog in inventory management, I will link everything here. The periodic review policy is basically another type of inventory management rule where instead of continuously reviewing when you are reordering, you do it like every week, every 2 weeks, every 3 weeks. So when my friend told me that they are every day checking their inventory, or he told me that it's an issue because they don't always have enough resources to do this. So what I propose to them is basically switching from continuous to periodic review policy. Great. So now let's go to the simulation. And let's imagine, right, that my friend is with me and he told me, okay, you did your calculation, please then tell me what to do, right? So for that, you can show your application. So here, this is mine, the LogiGreen app. This is an app that we have developed in the startup that I founded with my brother. It's basically a demo version to showcase the type of analytics product that you can use to help businesses for sustainability. So sustainability, we have some tools for supply chain optimization, where you need to locate your factories, warehouses to minimize cost or environmental footprint. We have a module for green inventory management. So this is basically how to optimize inventory management rule to minimize CO2 emissions. And we have a tool to simulate the circular economy, where basically we are simulating the environmental impact of renting products instead of selling them. So all these type of modules and basically solutions are detailed in my blog, and I'm going to publish some videos to explain all the details. You have some modules for supply chain optimization. This app can be accessed freely. Here you see there is no credential. You can use any module to test yourself. And this is a good complement to the different articles and videos I have on my channel. So if you are interested in this example here, so to help my friend to minimize his cash flow needs and maximize his profit, you go to business planning, then you go to inventory and cash flow. You will arrive at first page, it's kind of an introduction. You can see some visuals that are included in the presentation. And then you have the window for the different parameters. So here you have the button to launch the analysis. And as a first step, okay, as I told you, maybe let's put some kind of a baseline, right? So the baseline here is we are using the periodic review policy, and we are reviewing the inventory every 2 weeks instead of every day, what he was doing before. We start with 60 pallets. So it's what he told me, this was the initial stock at the beginning of the year. And here we are doing the analysis for the whole year. As he said, he wants to have 8 weeks of coverage every time he's reordering. He's using sea freight, so he has to wait 4 weeks to be delivered. And more importantly, what he told me is that the sales channel, so here the sales representative that he's working with are taking 30% of commissions. When he's selling with distributors is 0. Okay, let me launch it. Probably it's what you are waiting for. So what are the results? So here, the first page is showing the inventory management rule. What is linked with inventory is the cash flow. So here, basically what we can see is that, and here, yeah, sorry, I forgot this parameter. It's the initial cash on hand. So at the beginning of the year, how much cash he has in his company. And here, as we want to assess how our scenarios are good in reducing the cash flow needs, I assume that we have 0. And here the model will basically calculate the additional cash that he needs. So here he needs 84,000 euros additional to ensure that he can meet basically the demand during the year. And it's based on what? It's based on this inventory management rule, where here you have the customer demand, doesn't change. Here the ordering policy. So you see, you always order the same thing, basically for 8 weeks of the demand, where I think the demand is roughly 10 pallets per week. Here, all the units is in pallet. And here you have the inventory on hand. What you can see is that the inventory on hand is never below 0, so you don't have stock out. So you meet customer demands with something less stressful than checking the inventory every day, but you need 84,000 of additional cash. The second one, you have the cost and the turnover, which is quite interesting. Here, the most interesting thing is the logistic cost that we look at here. But in the last one, you have a kind of a summary, like executive summary, where you have all the profit, the average profit per pallet, this one KPI that we are going to look, and the cost of goods per pallet, goods of goods sold per pallet. So yeah, let's play. So I come to my friend and say, okay, look, this is probably the status quo. Let's say that I implement this inventory management rule for you. That's what you're going to need. But I'm not convinced that you need 8 weeks of storage, because now you have a robust inventory rule that is taking into account the demand variability and the demand during the replenishment. So what if you move to 6 weeks? And you know what? So here, as you can see, it's running automatically. My friend would say, yeah, but if we run to 6 weeks, probably we won't cover the needs. He's not really familiar in supply chain. It's a business guy. And what you can see here is that, the inventory management rule is done in a way that you are triggering, you order the right amount at the right time. So here, what we can see is that the inventory in hand, so how many pallets he has in his warehouse, is never below 0. So the demand is met, but the additional cash needed went from 84 to 34. So he's basically gaining 50,000. And then what he told me is that, okay, that looks cool. So what if, for instance, instead of using sea freight, I use air freight? Because air freight, and I explained him the stock, the safety stock is based on the replenishment time. So I say, yeah, okay, Samir, I want to use I want to use air freight so that I need less cash. Then I told him, okay, yeah, but it's probably not a good idea because air freight is too expensive. Say, yeah, but I want to try. Yeah, we can try. So here the profit, the cost of goods, let's look at the cost of goods, is 4,600 and the profit is roughly 4,000. So let's say he wants to move to air freight. If I remember where air freight is 3 times more expensive for him, it's the way that he has negotiated, but it's only 1 week of replenishment time. And let's say that here it's moving to 8 weeks, back to 8 weeks. So what we can see, first cash, no cash needed. Because of course, if you are replenishing 1 week, then the stock, the safety stock is lower and it's pretty good. And that's what we can see here. It's very low safety stock. It's very smooth. You don't need cash. Basically, why you don't need cash? Because, sorry, I didn't go in details. I'm a supply chain guy, but I should look at finance. Here you have the cash on hand evolution. So here it's basically the different flows. So when it's positive, it's money received. When it's negative, it's money to paid. And basically, when are you receiving money? When you are selling to coffee shops and bars. And when are you paying is when basically you have to pay the suppliers, where you have to pay the freight forwarders and the transportation. And what we can see here is that why it's positive is because you pay after you receive your turnover. So that's pretty good. But in terms of profitability, look, it's nearly, like you lost nearly, I think, if I remember, 900 euros of profit per pallet. It's terrible. So let's forget about air freight. Come back here. And then, I forgot here, replenishment 4 weeks. So then what I'll hold him is that, let me show you quickly here. What we can see is that we have some cash on hands because we have to pay, if I remember well, the supplier plus the freight forwarders, but we are still not paid by the distributors. So that's why we are here like a kind of negative that we need to absorb with the initial cash on hand. So what I wanted to tell him is, okay, here probably with the 6 weeks, we solved the issue of the initial cash on hand. But I told him, what about profit? Are you happy with the profit? Say, 4,056. It's something interesting, but I think I can get more. It's basically, he believes that his sales representative are taking too much money. So I say, okay, let's assume now that you only sell to distributors. Okay? Boom! The profit is exploding. But as you can see, the additional cash on hand is increasing. Because why? Because what happens is Here, you have huge spending, right? It's basically, you need to pay your inventory, you need to pay your transportation, but the distributors are paying later. So that's why you have negative cash flow, and you need to negative cash on hand, because you need to absorb, this kind of demand. And here, I mean, I think it's the second year of activity for him. The demand is pretty stable. Let's say that here, okay, you would tell me, yeah, but Samir, it happens only one time because it's the beginning of the year, but later it can be stabilized. Yeah, but his business is pretty seasonal. So probably later when he's going to develop his business, he's going to have some seasonality. So we need to make sure that we need to absorb this kind of peaks. So it's correct, but the profit is pretty cool. But still, we can, reduce this initial cash on hand to go back to 6 weeks. So to make the video brief, I will not go to more scenarios, but this is the kind of exchanges that we had. And then I showed him a table that I'm going to show you later, where you have all the different scenarios, and he was able to take a decision. Let's see that. Great, so back to the presentation. And just for the context, these are the same type of slides that I used with him and that I have put in my article. So here we have a table with all the different scenarios. So I started with the initial scenario, which is not really the initial scenario, but the scenario where I told him, okay, now forget about continuous review policy. I will help you to implement something periodic. Then I asked him, I told him, what about moving from 8 weeks to 6 weeks? And here what we could see is that we have a drop of the initial cash on hands, a reduction of the cost of goods sold, a small reduction, and a small increase of the profitability. Then he told me, what about air freight? I told him it's not a good idea, and what we can see is that it's definitely not a good idea. Even if you don't need cash, he can always ask the bank for additional cash now that he has a data-driven business model. It's in terms of profit, it's credible. It's not good. Then I told him, what about selling to distributors? And what we can see is that, of course, the initial cash on hand is more than double. Yeah, but the profit increase is terrible. It's nearly 140% increase. And for me, what I could define as the optimal scenario is that selling to distributors with 6 weeks of coverage, combining basically both. So that's the type for me. And I would say my job here stop at that level, because I'm not the business owner, I'm not the business decision maker, and I don't have all the parameters to take the right decision. But at least, with the analytics product that you have developed, you can help a business owner to test multiple scenarios. And actually, the discussion was way more deeper than this. We had way more scenarios to consider, but it's a great way for you basically to use your skills to bring visibility, understanding, and support decision-making for an executive or a business owner. So to conclude, what we have built here is a kind of a simulation tool with multiple modules. The main core module, and this is the main reason why my friend asking me, my support is the inventory rule. And then when I started to dig, understand the different financial flows, I add some additional cash flow. There is a cost module here. I didn't detail here, but basically just to bring visibility to my friends on the different costs. And here he could assess different parameters. He could assess different scenarios, change the parameters to see what would be the impact in the P&L, so the profit and loss, and the liquidity needs. So that's probably enough for the video. I hope it gave you enough insights on how you can use your analytic skills to help businesses. If you need more details, I will add in the description the 2 articles I wrote for this topic. I wrote a second article, I don't know if I'm going to do a video of this, but where I use the same model and now I test multiple pricing scenario to know what is the optimal pricing to maximize growth. If you want me to do a video about that, I can do it. And if you are interested also in the video, I have published a video for AI agents, and you will see the AI agents used for supply chain optimization, and you will see here the link. And see you for the next video.